Welcome back to the channel. Good to have you back. Let's focus on what gas laws. So I want to talk everything about gas laws. I want to focus on the ID gas equation. So therefore, I want to look at what the general gas equation to how to solve problem on general gas equation. Then I want to look at what the ID gas equation. After the ID gas equation, I want to look at what Darcy's law of partial pressure. I want to solve problem on that. Then Ground's law of diffusion. So look at them here. I'm not just going to teach you all these laws here. We have to solve problems over problems because now one thing about this thing here, there's a lot of calculation and you should be able to solve majority of the problem I want to see in your exam. So in this video, you have to break down every single thing for you. So make sure you have to pen your notebook and your calculator in order for to follow through at this video. If you have any question, leave it in the comment section. If you have any question, leave it in the comment section. And if this video is helpful, please don't forget to state in the comment section that this video is helpful. You understand? If you're not subscribed or you're new here, make sure you subscribe so that you cannot miss, so that you should not miss any other video I'm going to upload on the channel. So now let's get into it. So the first one to look at is what is the general gas equation. When we talk about general gas equation links pressure, volume, and what and temperature. So now we talk about general gas equation. General gas equation. Okay. So general gas equation means what? Is what P1 V1 over what T1 equals to what P2 V2 over what T2. Do you understand? So from here you can get three different laws. You can get the Boyle's law, Charles law, and what Geluz's law. Or yes, Geluz's law. So now if you should take from P1 V1 equals to what P2 V2. Now this one is one of the laws. So this one is supposed to this guy here. Do you understand? So this is called Boyle's law. It's called Boyle's law. And it occurs at what? At constant what? Temperature. Do you understand? Now when you link it again, you can find that you can link V1 over what T1 equals to what V2 what T2. Do you understand? This is called Charles law. This is called what? Charles law. Charles law. Do you understand? Now it occurs at what? At constant pressure. At what? Constant pressure. Now you can also link P1 over what T1 equals to what P2 over what T2. Do you understand? So here it's called Geluz's law. It's called Geluz's law. Geluz's law. And it occurs at constant volume. Do you understand? So now we're talking about general gas equation here. So depending on the question being given to you, now there you are going to what know the formulas to use. You understand? So we are going to solve a lot of problems. Like I told you, we are going to solve a lot of problems. So take this one down. It's very important. So this is the first thing you want to look at. Now the next thing you want to look at is what is the ID gas equation. ID gas equation. Do you understand? Now we're talking about the ID gas equation. Here we have PV equals what? nRT. Okay. Now this ID gas equation formula is a very useful formula. It's a very useful formula. So here I will do some derivation. Please make sure you take some down because we are going to solve a lot of problem with this one. Yeah, I'm going to show you how to solve problem. Now let's break this guy down. Let's break it down because at times in the point they say what is the mole of the gas? What is the mass of the gas? What is the density of the gas? You understand? So these are the type of questions you normally see in your exam. So we are going to break this down. So PV equals to what? nRT. Now, where P is what is the pressure, V is what is the volume, N is what is the mole of the gas, R is what is the gas constant, T is what is temperature. T is what is temperature. You understand? So now we want to try to break this down. So I'm just defining this one here. P equals to what? Pressure. V equals to what? Volume. Idea. And the unit of pressure is what is ATM. It must be what in ATM. The unit of pressure must be what in dm cube or liter. Very important. Then N is what is mole. N is what is the mole. Then T is what is temperature. and it must be what in Kelvin. Please follow me closely here because we are going to if you don't follow this class step by step, you may miss out. You get so now. R is what is the gas constant. Gas constant. I get gas constant, and the value. Tell me what a value. The value of R here is what 0.0821 atm liter per mole per watt per Kelvin. It's okay per mole per Kelvin. So you have to what takes it down 0.0821 atm liter per mole per watt per Kelvin. So these are things you need to what take note of. So just rush pause the video and watch and what takes from that because we are going to what make it of everything here. So it means that when you are solving problem under what the ideal gas equation, now pressure must be in what in atm, volume must be what in dm cubic liter, n must be what in mole, t must be what in Kelvin, which is K. Then the R is what is gas constant, which is what mole per liter, no atm liter per mole per what per Kelvin. So now let's imagine that a question is being given to you that you want to calculate the mole of the gas. Either you want to calculate the mole of the gas, what you want to do here is what next one is solving the formula. So when a mole of the gas is being asked to calculate, that is you know the pressure of the gas, you know the volume of the gas, you know the what temperature of the gas, and there must be what in the right what unit. You understand? Like what I say, pressure must be what in atm. So whenever pressure is not given in atm, then you need to convert what you need to convert what to atm, which I'm going to teach you. Don't worry, I'm going to teach you that. Now, here you need to convert what to liter or dm cube. So whenever what the volume is not given in what in dm cube or liter, you need to convert what to dm cube or liter. So how do you convert this? How do you convert all these things here? I'm going to teach you as we move on. Then you must convert what degree centigrade to what to Kelvin. You get therefore you can now what to use from here. But in a situation when you are being asked to calculate the mass or the molar mass of the gas, so how are you going to do that? So if for example now it's related to what to mass or molar mass of the gas, it means that we have to break this thing down. Okay. So now remember mole equals to what mass over what molar mass, right? So this is another formula you need to take note of here. N equals to mass over what molar mass, right? So now let's impute this one here. So I have to impute everything down to here. So it means that PV equals to what mass over what molar mass times what R what T. So from here now I can what make mass solve formula what make molar mass what solve formula here. Now if for example now they say what's the molar mass of the gas? Again now the gas not begin to say well calculate what molar mass of the gas. Now we want to what make this molar mass the solid formula here. Just now. So when you make this molar mass the solid formula here, when you have to what to cross multiply. When you cross multiply, it's going to be PV times molar mass equals what mass R what T, right? So making molar solid formula here, we have divided both sides by what PV over what PV, right? So my molar mass of the gas is equals to what mass times what RT or what PV. So this is what on that formula you need to what take note of. So so you need to what write it down. So you have molar mass equals to what mass times what RT over what PV. So this is what on that formula you need to take note of. So this is what the ideal gas equation. So I'm breaking it down to what to get some mass. Molar equals to what mass times RT over PV. You understand? So now let's imagine that we are being asked to calculate the mass of the gas. Do you understand? Not the molar mass again. So from here now, if you are being asked to calculate the mass of the gas, what I'm going to do here, I'm going to what make mass the solid formula, right? So if I should make my solid formula, if I should what make mass the subject of formula, what am I going to do here? I will divide both sides by what R what T. So it will cancel out. So my mass of the gas equals to what PV times the molar mass over what R what T. Can you see that? So that is I have another formula that I say what mass. Oh, there's no space here, so but let me manage it. Mass equals to what PV times what the molar mass over what ROT. Look at something here. Whenever you are solving ideal gas equation, you cannot escape question from all this I'm showing you because you are going to see questions for question here. So that's why you want to pay close attention. Now, what about it now relate to what to density? Because most times you say what is density of the gas? You understand what is the word density of the gas? So how do we relate density here? So we are still going to use if you look at what the formula for density. So what is density? Density equals to what mass over what volume, right? Mass over what volume or density. Density of the gas, density equals to what mass over what volume. So I just want to use the symbol D. You understand? Density equals to what mass over what V. Do you understand? So what I want to do here is this. Now remember, N equals to what mass over what molar mass. The density equals to what mass over what volume. So now you find that this one is what is this formula here, and V is what is this formula is here, right? So what I want to do here, I will make V the solid of formula. Please follow me close here. So when you cross multiply, now it's going to be D times V equals to what mass, right? Making volume the solid formula here, it's going to be V equals to what mass over what density. Do you understand? So now this is what I'm going to do here. I'm going to substitute these two formula. I'm going to substitute N equals to mass over molar mass and V equals to what mass over density into what this formula here. And make sure I'll make density the solid formula here. You understand? It's very easy. So now let's go back to this one here. So I'm going to have what P times. Now what's my volume? My volume is what mass over what density, right? So it's going to be mass over what density, right? Equals to. Now what is my N? My N is what mass over what molar mass. So it's going to be mass over what molar mass, right? Times ROT. Now the idea here is that density should be the solid formula. You understand? So you're making density solid formula here. So if you have something like this, so it means that I'm going to have P mass over what density equals to what mass ROT or the molar mass, right? So what I want to do here is what cross multiply. When you cross multiply, okay, remember this one is also mass. So here we have mass. So when you cross multiply, it's going to be D times mass ROT equals to what? P times P mass times what? Molar mass. Do you understand? So making D the solid formula here, density solid formula here. So we're going to have what? Divide both sides by what? Mass ROT over what? Mass ROT. You find that this one will cancel out this guy here, right? You find that mass will cancel out what? Mass, right? So it's going to be D equals to what? P times molar mass over what? ROT. Look at something here. In the exam, you don't need to derive all these things. So I'm just trying to want to derive this formula for you so that you know how this formula be derived. Look at something here. Because as a student, what makes you a good student of chemistry or any subject at all is your ability to derive formulas like physics. If you're a physics student, I don't know how to derive formula, then you are not a good physics student. You understand? If you're a mathematics student, I don't know how to prove some formula, then you're not a good mathematics student. You get? And if you're a chemistry student, I don't know how to prove some equations, then you're not a good chemistry student. You get? So I'm not just giving you this formula, I'm showing you how this formula be derived, because most times we can forget these formulas. But if you can start mastering this derivation, it's going to help you in a long way. You understand? And you're going to give you an understanding how you can use this formula in solving problems. So that's why you want to pay close attention. If you're following my thermodynamics video, you start at derive formulas. After deriving the formula, we also use the formula to solve problems. Do you understand? So it's not like I'm just trying to try to make to derive this thing here, because it's very important. Do you understand? So now I have my first formula, my second formula, my third formula, I want my fourth formula. So I'm going to wipe everything. D equals to what? P times molar mass over what? ROT, right? So these are all the formulas I'm going to make use of. Remember, I also have this one, right? So I want to introduce this one here. So you have P while V1 about T1 equals to P2 V2 or T2, right? Also about this one here. So, but from here, I can get the rest of this guy, right? So, these are all the formulas we're going to make use of in the what ideal gas equation, like gas law calculation. Do you understand? So now let's look at the first three set of questions. So you can see them on the board here. These formulas are just here. So these are what? These are our questions, first three set of questions. So let me show you how you can start solving problem with this formula here. So now the question will tell you the kind of formula to use by looking at what by the parameters. You understand? So let's look at the first one here. Solution. Let's look at the first one. Look at 3.6 grams of nitrogen gas are placed in what? In a 5.00 dm cube container at 27 degrees centigrade. What is the pressure of the gas? So now let's look at what the question very well. So now here, the mass of the gas was given to me, mass of N2, because is what is nitrogen. Mass of N2 is what? 3.6 grams, right? Now, are placed in a what? In 5.00 dm cube. So dm cube is what? Is volume. So you can say volume of the gas is what? 5.00 dm cube, right? Now contained at 27 degrees centigrade, right? So my T, my temperature is 27 degrees centigrade. You understand? Whenever we are solving gas law problem here, you must always convert what degree centigrade to what? To Kelvin. And how do you convert centigrade to what? To Kelvin? Is by what? Adding 273. So if you want to convert degree centigrade to Kelvin, you are going to add what? Plus 273. Do you understand? So it's going to be what? 300. So it's going to be 300 what? Kelvin. Do you understand? So there we what my temperature, 300 what? Kelvin. Now that's what is the pressure of the gas? So P, that's what I was looking for. So now let me ask you here, which formula are you to use? Which formula are you to use in this what question here? So now, because we are looking at our pressure, they gave us what? Mass, right? So it means that you can easily what use this what formula here, because here we have molar mass ROT or PV. So what we want to do here is what? Make what P the solid formula. You can also make use of this guy too. You understand? You can also what make use of this guy. So if you want to make use of this guy here, then I have to look for what more of the gas, right? So like I say, using PV equals what? nRT, right? From here now, let me look for what? For the mole of the gas, right? I know that mole equals what? Mass, what? Molar mass. So the question will be, what is the molar mass? Molar mass of what? N2. Right there. The atomic mass of nitrogen is what? Is 14. You understand? So 40 times 2 is what? Is so let me 14 times 2 is going to be what? 28 gram per watt per mole. Do you understand? So here we can see that the molar mass, here we can see that molar mass of what? N2 equals to what? 28 gram per mole. Do you understand? So from here, I can either what? Look for what? For the mole. Do you understand? Can you look for the mole? So the mole is going to be what? Mass. What is my mass? 3.6 gram. But the molar mass is 28 gram per watt per mole. What will not be the answer? So it will be 3.6 divided by 28. So you have 0.129 what? Mole. You understand? So yeah, since we are looking for for pressure, because they're asking what is what pressure, right? So since we are looking for pressure, what we want to do is what? Make P the solid formula here, right? So if I should make P the solid formula here, I'm going to have P equals to what? nRT over what? V. Do you understand? Remember, R is what? Is a gas constant, right? What is the value for R here? My R here is what? 0.0821 ATM liter per mole per watt per kV. This that. So here I have what the mass, which I've used to calculate what the mole already, right? Here I have what my volume. Here I have what my temperature, which is what 200. Here I have what my molar mass, right? So what I want to do here is that let's apply it formula here. So it's going to be P equals to what? nRT over what? V, because we make P formula here, right? Equals to what? Where's my mole? My mole was 0.129. 0.129, right? Times. Now, where's my arrow? My arrow is what? My arrow is 0.0821 times. Now, where's my T? My T is what? Is 300, right? Over. Now, my V is what? 5.0 dmq, right? Let's leave it like that. You get. So, what I want to do here? What I want to do here, we just first work punch our calculator. We want to get our answer. 0 dot 0.63 what 5 watts. Now, what will be the units? The unit what is ATM. Right there. Now, if this one is, please look up. If this one here is exam question, look at something here. It is what is a theory question. Now, after this one here, please understand this here. If after solving this question here, you know what, do the unit analysis. You must give the unit analysis. It's very important to what, give them the unit analysis. After about we have what an ATM as units. So this is where I want to do unit analysis. You get. So for every theory question, after solving the problem and getting the answer, you must do unit analysis. It's very important. So let's do unit analysis here. Let's do unit analysis. Very important. Unit analysis. Unit analysis. So I want to say unit analysis. Unit analysis. Unit analysis. Unit analysis. Here we use this formula here, right? P equals to what? N arrow T or what? V, right? So now, what is the unit of what? N? N is what? Is mole, right? Times. What is the unit of what? Arrow? Arrow is what? ATM liter per mole per Kelvin. So it's going to be ATM dm cube per mole per what? Per Kelvin, right? Times. What is T? T is what? Is temperature, which is what? Is Kelvin. Over what is my volume? My volume is what? Is dm cube. You understand? Again, I that liter and dm cube are the same thing, right? So if you should break it down, you find that dm cube becomes our dm cube, right? Kelvin becomes our Kelvin, and per mole becomes our this mole here. So you can see that the unit is now what? ATM, which get our answer here. It may look as if it's very important. Listen to me carefully. It may look as if it's very important, but now they expect you to what, do this unit analysis for them. Show them how you arrive at what, at your as well at your what units. You understand? So it's just like unit analysis. You have to do it and what, get your answer. With this time, you have got your full mark. I'm saying that if this question is what is theory, but if it's subjective or objective, is not important. You want to what, give them this formula. Give them the answer what, go your way. Do you understand? So that is it for the what, first question. If you are following this class here, please leave a comment section that you are following this class. And if you are enjoying this class, leave a comment section that you are enjoying this class. If you are not subscribed to the channel, please hit that subscribe button. And if you have not liked the video, please like the video. So then look at what question 2. Question 2 is that compute the density of propane gas at STP, assuming ideal gas behavior. Assuming what ideal gas behavior. Now, it says you will compute what the density of propane. You understand? And you know what? Not the word molar mass of propane, right? So, solution. Solution. So, first of all, let's get the what propane formula. Propane is what is an alkane, right? For those of you who know organic chemistry, is what is an alkane. And we talk about propane, we are talking about 3 carbon atoms, right? So the formula for alkane is what? CnH2n plus 2, right? If you impute 3 here, because propane is what 3 carbon atoms, if you impute 3 here, you have to have C3H8. So this is what molecular formula for what? For propane. Now, when they say you calculate, they say well, compute the density of propane. So here you are looking for density of propane, right? Now they say that at STP. Now, what do you understand by STP? Standard temperature and what and pressure. That is called at STP. So we talk about at STP. That is Pressure we have its own what value, standard value. Temperature we have your own standard value, and volume we have its own standard what value. So at STP, look at some at STP, P is equal to what 1 atm. Right there. Then temperature is what 273 Kelvin. Do you understand? 273, yes. So we're talking about a constant temperature. No, at STP 273. 273. Then volume is what 22.4 dm cube. Do you understand? So now they're talking about density, and the formula to calculate density is what D density equals to pressure times the molar mass, or what ROT. So this is the formula we are using. D equals what pressure times the molar mass over what ROT, right? So we know our pressure, we know our temperature, right? We know our pressure, we know our temperature, the gas constant, which is what R equals to what 0.0821 atm dm cube. Let's use dm cube per mole per what per kg. It's very important. Don't forget this one here. Now, what is molar mass? So we need to calculate the molar mass of this guy here. So molar mass of C3H8. You understand? If you should miss this one here, you remember they just say propane, and molar mass is not the molecular formula is not given to you. You have to find it yourself. Okay, that is why as a chemistry student you need to think on and need to know what you are doing. So here we have what. Now, what's the atomic mass of carbon? Atomic mass of carbon is what is 12. 12 times 3, right? Plus. What the atomic mass of hydrogen is what? Is 1. 1 times 8, right? So what are you going to get? You're going to be what? So we have 44 gram per watt per mole. Very important. 44 gram per watt per mole. So what I want to do here is this. Impute your values here, right? So if you impute our value, because we know our pressure, so going to be D equals what? What is P? P is what? 1 times, what is molar mass? Molar mass is what? 44 over, what is R? R is what? 0.0821 times, what is T? T is what? 273. Now, I'm not supposed to say chemistry. I'm not going to use one here. The formula does not include what? Volume, so it's not needed. Do you understand? So what I want to do here is what? Bring out your calculator. 1.963 gram per watt liter, or dm cube. Do you understand? So now let's look at what unit analysis, because it's very important to look at what unit analysis. You understand? So gram, the unit of what of density is what? Gram per liter, right? Or gram per dm cube, right? So let's look at what unit analysis. Quiz, is this unit analysis important? The answer is yes. Yes is what is a theory question. Enough for you to get a 2 mark. Enough for you to get a full mark. It's not just enough to just take it like this. You have to do some unit analysis for them. So let's look at what unit analysis. So I'm going to do it down here. Unit analysis. So here we have unit analysis. Unit analysis. Unit analysis. So let's at it. D equals to what? What is my P? My P is what? What is it? What is unit of what P? P is what? ATM. So here we have ATM times. Now molar mass is what? Gram per mole, right? Gram per what mole. So it's going to be gram per what per mole, right? Times. Okay, there's no times here, right? So P is what? Is ATM. Molar mass is what? Gram per mole over. R is what? Is the gas constant, right? So what is the unit of what gas constant is what? ATM dm cube per mole per Kelvin, right? Times, here we have T, which is what? Kelvin, right? So now let's break it down. Because ATM cancel our ATM, right? What is again? Per mole cancel what? Per mole, right? Kelvin will cancel what? Kelvin. We check it with them. What is left is what? Gram over what? Dm cube. What? Gram per dm cube, which is this guy here. So chemistry, is it important? Yes, it's important. You get. So let's look at what question 3. Let's look at what question 3. So take that so I can move to what question 3. Together here, it's that a gaseous sample weighing, so that is how what mass of the gas is what is 0.896 gram, right? That is what gaseous mass of the what that is what mass of the gas, right? Now what is volume? The volume is what the volume is 524 cm cube. Now look at some cm cube. Are you there? So now this is where I want to actually explain something here. Now cm cube, so this thing known as mil. Are you there? Cm cube is always thing known as mil. So whenever I see cm cube, you have to talk about what mil. Then dm cube, this thing known as liter. Do you understand? So how do you convert from cm cube to what to dm cube? Or how do you convert from what milliliter to what to liter? Now remember there is a relationship. One dm cube is also the same as what 1000 cm cube. Do you understand? Very important. One dm cube equals to what 1000 cm cube. Or you can say 1 liter equals to what 1000 what mil. Is it clear? Remember, liter and dm cube are the same thing. Mil and cm cube are the same thing. So it means that you have to convert this cm cube to what to dm cube. Do you understand? So you have to use this conversion factor here. This relationship. 1 dm equals to 1000 cm cube. Now when you're converting, you bring what the relationship here. Understand that you must arrange units in a way that will cancel each other, right? Now, this cm cube have to go to the down. So here we have 1000 cm cube. Why 1 dm cube have to go to the top? So now the main reason why I do like this, so that cm cube will cancel out cm cube. Do you understand? So guys, you must know how to convert from one unit to the other. It's very important. You must understand how to convert from one unit to the other. So you must arrange, therefore know the relationship. So we are converting what cm cube to dm cube. So what is the relationship between cm cube and dm cube? The relation is that 1 dm cube is always equal to what 1000 cm cube. Do you understand? So you must arrange such a way that cm cube cancels out cm cube. And the only way to achieve that is that it should be at the down. So this you cancel out this one here. So why this is at? So what you have here going to be 524 times 1 divided by 1000. So you have to have 524 divided by 1000. Here we have 0.524 dm cubed. So that would now be what the volume 0.524 dm cube. Do you understand? So that is what for the volume. Now, isn't that at 760 watt millimeter mercury? So by pressure, this was 760 watt millimeter watt mercury. It's okay. Now, remember, pressure must be in what in atm. When you talk about what the ideal gas equation, pressure must be what in atm. Remember, in pressure conversion, 1 atm is equals to what 760 millimeter watt mercury equals to what 760 watt torque equals to what 101325 Newton per meter square. I get all Pascal. So this is what the relationship here. You have to take it down. So since here we have 760 millimeter mercury, right? That is going to be what 180. Just that because 180 equals what 760 millimeter mercury. The question gave us what in 760 millimeter watt mercury. What does it mean? It means we have to convert what to 18. Do you understand? The next one we want to look at, so you can take some down. The next one to look at is what the what temperature. My temperature which is T is what? My temperature which is what? 280 centigrade here. Why you wouldn't want to convert to Kelvin? When you convert to Kelvin here, we have 28 plus 273. What is the answer? So let it be 28 plus 273. Here we have 301 Kelvin, right? So these are all the parameters given to us. So what else you should look for? The molar mass of the gas. So you can say what molar mass of the gas. That's what you are looking for, right? You don't know. So from here now, let's pick the formula to use. We are going to use this formula here because this one look what molar mass equals what mass times ROT or PV. So you can say molar mass equals to what mass times what ROT or PV, right? So what will happen here? So my mass, what is my mass? My mass is what is 0.896 times my R is what? Okay, remember R is always constant 0.0821 ATM dm cube per mole per kg. So we know that one here. So we got to be what 0.0821 times T. My T is what 301 over my P. What's my P? My P is what 1 times my V is what 0.524. Just that. So molar mass goes to what 42.25. So let's our next set of questions. We have a question 4, 5, and what 6. So I want to like first. They say that a sample of nitrogen gas occupies a volume of 300 ml at 27 degrees centigrade and 600 meter mercury of pressure. What would be its volume at STP? So let's say I can solve the question here. That a sample of nitrogen gas occupies a volume. So here we have you can see that we have what we call phase volume, phase temperature, and what phase pressure. So here we have P1. Sorry, here we have V1 to be what 300 what mil. Now here we have T1 to be what 27 degrees centigrade. And here we have P1 to be what 600 millimeter what mercury. You understand? Now they're asking what would be its volume. So that they're talking about V2, right? At STP. Remember, at STP is what we call standard temperature and pressure. So here we have T2 and what P2, right? So at STP, here we have 273 Kelvin, right? 273 what Kelvin. 273 what Kelvin. Then P2, remember P2 at standard what pressure. At standard pressure here we have 1 atm equals what 760 what millimeter mercury. Now 6 years only what in millimeter mercury, here would be 760 millimeter mercury. Do you understand? So the only thing I want to do here is that I want to combine this one to what to Kelvin by adding 273. So if you should add 273 here, so it will be 27 plus 273 equals to what 300. Here we have what 300 what Kelvin. So we have to use the general gas equation, which is this one here. So I want to use P1 V1 or T1 equals to what P2 V2 or T2. Can you see that? So what I want to do here is to what is to make V2 itself formula here, right? How do you make V2 itself formula here? When you cross multiply, what are you going to get? Here we have P2 V2 T1 equals to what P1 V1 T2, right? So you should what make V2 itself formula here. You have to divide both sides by what P2 T1 P2 T1, right? So you have V2 equals to what P1 V1 T2 over P2 T1, right? So if it's your value there, T1, P1 is what 600 millimeter what mercury times V1 is what 300 what mil times T2 is what 273 what Kelvin over. Now P2 is what 760 millimeter mercury times uh, T1 is 300 what Kelvin, right? So you can say that meter mercury cancel out meter mercury, Kelvin cancel out Kelvin, right? So you want to punch your computer to give your answer. So you have 600 times 300 times 273 divided by 760 times 300. Whoa. 600 times 300 times 273 divided by 760 times 300. So the answer here is 215.52, right? The 5.53 milliliter, right? Because the volume is milliliter, so it will be milliliter. You understand? So it means that V2 is equal to what? 215.53 what milliliter. That is what? That is the answer. Do you understand? So that is the first question. Let's look at question 5. Let's solve question 5. A sample of CO2 occupies 350 cm cube at 20 degrees centigrade and 104 kilopascal. What pressure is needed to compress it to 250 cm cube at the same temperature? So what we want to do here is to write out all the parameters. So you have we get have V1. So V1, that is initial what volume. V1 equals what? 350 what? Cm cube, right? Now you have T1 equals to what? 20 degrees centigrade. Remember we talk about it to Kelvin. So it will be 20 plus 273. Yeah. 20 plus 273. You have 293 Kelvin, right? 293 Kelvin, right? So you have P1 equals to what? 104 kilopascal. Next that, what pressure is needed to compress it to? So my V2 is what? My V2 is what? 250 what? Cm cube, right? Now, at the same temperature, that is temperature will remain the same. That is T2 remain the same to what? 293 what Kelvin. Do you understand? Temperature what remain the same. So they're asking of what? Of the pressure. So they're looking for P2 here. You find that you are still going to, if you should use the general formula, P1 V1 over what? T1 equals to what? P2 V2 over what? T2. You find that these two are the same, so you cancel the arts. These two, T1 and T2, are the same, so it's not important. So that is using what Boyle's law formula. P1 V1 equals to what? P2 V2. Now what are you looking for? You're looking at what? T2. So if you make T2 yourself formula here, so you have P1 V1 equals to what? P2 V2. Make it P2 yourself formula here. Divide by what? V2, right? So that is my P2 equals to what? P1 V1 what? V2. So what happened here? Impute your formula. P1 is what? Is 104 kilopascal times V1 is 350 cm cube over, now V2 is 250 cm cube, right? So what happens? So we cancel this one here. So we use the calculator to push your answer. So you have 104 times 350 equals to what? 250. So you have 145.6. Now, what is unit? The unit is what? Kilopascal. Kilopascal. Do you understand? That is the answer. Do you understand? So, let's have question 6. A gaseous oxygen at 27 degrees centigrade. So, that means my T, if you check very well, gas oxygen at 27 degrees centigrade has a molar volume of 0.227 liter, right? Calculate the pressure exerted by the gas if the oxygen is an ideal gas. So you're talking about ideal gas equation. In ideal gas equation, using what? PV equals to what? NRT, right? Let's write out all our parameters. If you write all our parameters, T is what? 20 what? 7 degrees centigrade. Now, remember, you need to convert to what? To Kelvin, right? By adding 273. So if you add 273 here, 27 plus 273, 27, 27 plus 273. Here we have 300. Here we have what? 300 what? Kelvin, right? So here as the molar volume, that is V is equals to what? 0.227 what liter, right? Now I say what calculate pressure. So that is my N. By mode is going to be 1. You start when we our molar volume, that is my N is what? Is 1. My N is what? Is 1. So and more was not given to me, and we are used on here. So they were say she look for, right? We know this one, we know this one. My R is what? R equals to what? 0.0821 ATM liter per mole per what? Per Kelvin, right? So that is because we are looking for what? P. So what do we have here? P going to be what? NRT over what? V, right? So we are using P equals to what? NRT over what? V. My N is what? My N is what? 1 times 0.0821 times T is what? T is what? 300 over V. My V is 0.277 227, right? Now let's get our answer. So we have 1 times 0.0821 times 300 divided by 0.227. So you have 108.5150. So what is unit? The unit is going to be what? ATM. You understand? This unit is going to be what? ATM. So that will be the end of this class here. I believe this video is helpful, and I believe you are able to solve. You'll be able to solve most problems now when you see them under what? Gas laws, ideal gas equation, right? So I don't want to go into gas law of dilution and that law of partial pressure. That will be going to be what next video. That if you have not watched our previous video on thermodynamics, the first law of thermodynamics and isotopic expansion of an ideal gas, so you can check out this video to watch that video to make sure you can check out this video here.